So, from the special relativity, Einstein derived the new theory, the general relativity, which made a new description of gravity. The postulate is equivalence principle. Observers cannot distinguish locally between inertial forces due to acceleration and uniform gravitational forces due to the presence of massive bodies. So here is a person, he feels, I feel gravity, I must be on the surface on a planet. And here also I feel gravity, I must be on a surface of a planet. And this happens due to the presence of massive bodies that we will see they are bending space and time, and it makes them to feel that feeling. Another explanation for this is you imagine a light source, and when the light source is seen by a stationary observer, an observer that is stationary, he's not moving, the light just passes straight. But when it is seen by an observer on board the ship, the light will appear to bend, and it bends because of gravity. When this acceleration, it is this way, it's opposite to it, the acceleration of gravity, and that causes bending, and this means that gravity can bend light. So light coming to us is not just straight on the big scale in the cosmos, it bends because of huge massive bodies. It only bends from massive bodies, stars and so on. So for the accelerated observer, the light ray appears to bend downward, as we said. Now we can distinguish between this inertial effect and the effect of gravitational forces. Thus a gravitational force equivalent to the inertial force must also be able to bend light. And that's because imagine you are holding a paper, and on this surface of paper, that soft thing, or a piece of cloth, a huge piece of cloth, and you put a watermelon on this piece of cloth. What will happen is this piece of cloth will start to bend. It will start to bend. This what happens to space and time. It starts to bend, and when this happens, it will start to attract bodies to it. Because if you put a table tennis ball on this piece of cloth that is bended towards the watermelon, it will start to go and accelerate towards the watermelon, unless there is a velocity that this table tennis ball is having, that will cause the table tennis ball to revolve around that other body. So space and time bends because of huge massive bodies, and this also causes something called gravitons to start to interact between both massive bodies. It's like when you play with the racquetball, and you start exchanging these particles, and the more massive, the more these particles are. So even light can start to bend. You see this piece of thing like the cloth, and this is the huge watermelon, the sun. So even light starts to bend. So when it bends, reaching the earth, we can see the extension of that line, seeing the star in another position. So this means that a star hiding behind the sun, and this happens in total solar eclipse. We can see stars hiding behind the sun, like this one. This is a star hiding, but we can see it because when the light bends, we see the extension of the line. So this proves that space and time bends, and the light bends because of gravity. And this is how the general relativity explained the gravity phenomenon. There is also something called gravitational lensing, and it happens because of galaxies. Galaxies start to bend light like it's a convex lens causing a lensing. It's like making galaxies appear nearer or bigger. And that was our lecture today, and thank you. I hope you liked it and enjoyed it and found it beneficial.